In this video, we're going to go over the answers to pages. Module 3, page 170 to 173. Again, any questions after you've looked over the video, perhaps rewatched the video, contact me through Remind or email. We need to match up 3 of these equations with 3 of the graphs, and then whatever equation wasn't matched up, we needed to create a table and a graph for it. Well, in the previous video, we rewrote these in slope-intercept form. Y equals 6, in slope-intercept would be y equals 0, x plus 6. This would be a graph that crosses at 0, so this isn't it. Crosses at 0 and goes up by 6. So no matter what value I put in for x, if I put x equals 1/6, 0 times 1/6 is 0, and y equals 6. If I put a 0 in for x, 0 times 0 is 0, so y equals 6. If I put a 1 in for x, 0 times 1 is 0, so y equals 6. So this is 1. This is y equals 6. No matter what value I put in for x, y always equals 6. This one, y equals 1/6x plus 0, or just y equals 1/6x, that means this line is proportional. It's a straight line, and it crosses through the origin at 0, 0. This point crosses at 6, so this is definitely not it. We've already done this one. This line crosses at 0, so it has a possibility. And does it have a rate? Does it go up 1 and forward 6? Well, if it does, if it goes up 1 and forward 6, that means that this point on the graph is approximately 6. Up 1, forward 6. And since 5 is there, 10 is there, yeah, that looks right to me. That looks like coordinate where x is 1, y is 6. When x is 2, or excuse me, when y is 2, when x is 12, y is 2. So that also looks like it works out. The coordinate when x is 12, y is 2. When x is 6, I made a mistake there, I'm sorry, y is 1, that's where I was wrong. So when x is 6, y is 1. When x is 12, y is 2. And this is y over x. And so 1/6 means this goes up 1, goes forward 6, the slope. It goes up 1, forward 6, up 1, forward 6, up 1, forward 6. And so it has a slope of 1/6. So that is letter C. Number 3, we're looking for a negative slope. For it to go, a slope that goes, as x gets bigger, this slope goes down 1. So, and it crosses at 6. Well, this crosses at 6. Does it go down 1? From 6 down to 5 and out to 1. So down 1, forward 1, down 1, forward 1, down 1, forward 1, down 1, forward 1. So this does have a negative 1 slope. It goes down 1 for every 1 forward. So y decreases by 1 as x increases by 1. That means this is the one that wasn't graphed. This, the one was 2x plus y is 6. I rewrote it in slope-intercept form. So y equals negative 2x plus 6. That means this crosses the y-intercept at 6. So I just scaled my y 2, 4, 6. It crosses right there. And it has a slope of negative 2. It goes down 2, forward 1. Because again, negative 2 is the same as negative 2 over a 1. Down 2, forward 1 is going to be the slope. Down 2, forward 1, down 2, forward 1, going down the stairs. You go down 2, forward 1, down 2, forward 1. And let's just put some values in. If I put in a 0 for x, negative 2 times 0 is 0, so y equals positive 6. When x is 0, y is 6. That would look like y equals negative 2 times 0 plus 6. Again, we're putting a 0 in for x. Negative 2 times 0 is 0, so y equals 0 plus 6. So when x is 0, y is 6. That's a coordinate on this number line, or on the graph. And that's this one right here that we had. When x is 1, negative 2 times 1 is negative 2, plus 6 is 4. When x is 1, y is 4. When x is 2, y is 2. When x is 3, y is 0. And this is decreasing when x, again, down 2, forward 1. So it goes down 2 units of y, forward 1 unit for x. A tank that currently holds 2,500 gallons gallons of oil is being emptied at a rate of 25 gallons per minute. The capacity of the tank is 3,000 gallons. So I did my high-quality artwork over here showing a full tank would have been at 3,000 gallons. Where it's at right now is 2,500 gallons. Empty is at 0 gallons. And pouring out of a spigot, it's losing 25 gallons every minute. So I used a negative because the volume is going down 25 every minute. How many gallons are currently in the tank? Well, 2,500 gallons. How fast is the tank being emptied? The rate's going down 25 gallons every 1 minute. So that's its unit rate. What two quantities are changing? Well, I've got volume of oil and time in minutes. Define the variables. Well, volume is gallons left. I let that be G for gallons of oil, and that variable is dependent on the time. And then time is in minutes. I just used a T as my independent variable. What is the unit rate of change in this situation? Explain. I'm losing 25 gallons every minute, and again, a unit rate has a 1 in the denominator. Has 1 unit in the denominator, and since the volume is decreasing, I used a negative number. Write an equation that relates the two quantities. The volume in gallons remaining is the 25 gallons that are emptying every minute from the 2,500 that it started with when I got here. Now, again, note, in terms of y and x, output is negative 25x plus 2,500. I can change the variables. This y and g, the dependent variable, and the independent variables are the t and the x, because x will be the independent value, and in this case, I'm just letting a t represent it. This is slope-intercept form. How many gallons will be left in the tank in a quarter of an hour? Again, a quarter of an hour means the time is 15 minutes. And so I'm using this equation over and over again. Gallons equals negative 25t plus 2,500. And I'm substituting 15 for this t. Gallons equals negative 25 times 15, because it's times that t, plus 2,500. I multiply those two. Gallons is negative 375 plus 2,500. Combine gallons left is 2,125. After 5.5 minutes, gallons is negative 25 times 5.5 plus my start value. So gallons, when I multiply those two, negative 137.5 plus 2,500. Combine those. Gallons is 2,362.5 gallons left. After an hour and a half is 90 minutes, so t equals 90. So g equals negative 25 times 90 instead of the t, plus 2,500. G equals, I multiply those two, negative 2250 plus 2,500. Combine those. G equals 250 gallons left. When will the tank be half full? Well, totally full is 3,000 gallons, so half full is half of that, 1,500 gallons. So when G equals 1,500. And again, our original equation is G equals negative 25T plus 2,500. And I just substituted a 1,500 for the G. 1,500 equals negative 25 times T plus 2,500. Subtract 2,500 from both sides. 1,000, negative 1,000 equals negative 25T. Divide both sides by negative 25. T equals 40. So the time is 40 minutes. So half full and 40 more minutes. When will it be empty? So empty is 0 gallons. So let 0 equal G. 0 equals negative 25T plus 2,500. Subtract 2,500 from both sides. Negative 2,500 equals negative 25T. Divide both sides by negative 25. 100 minutes equals T. How long ago? So before you arrived, because when you arrived, oil was pouring out, but it was at 2,500 gallons. So sometime before you arrived, it was at 2,600 gallons. So when G equals 2,600, I'm going to put a 2,600 in. 2,600 equals negative 25T plus 2,500. Subtract 2,500 from both sides, subtraction property of equality. 100 equals negative 25T. Divide both sides by negative 25. Negative 4 minutes equals T. Negative 4, in this case, negative 4 minutes means 4 minutes before you arrive, 4 minutes ago. How long ago was the tank full? Well, full means 3,000 gallons, so we're going to let G equal 3,000 gallons. 3,000 equals negative 25T plus 2,500. Subtract 2,500 from both sides. 500 equals negative 25T. Divide both sides by negative 25. Negative 20 minutes equals T. And again, negative in this case means 20 minutes before you arrived, 20 minutes ago. Last page. Complete the table. The quantities that we're working with in this problem are time and volume of oil. Time is given in minutes. Volume of oil is given in gallons. We let time equal T. If you use different variables here, it doesn't matter. I just used a T and a G. And I'm just putting my values in. So from the previous problem I worked, I'm just using those. I said negative 20 minutes was 3,000. Negative 4 was 2,600. When I arrived, it was at 2,500. 5.5 minutes after I arrived, it was at 2362.5. 15 minutes after I arrived, there's 2,125 gallons of oil left. 90 minutes after I arrive, there's 250 gallons of oil left in the container. And after 100 minutes after I arrive, it's at 0. So anything more than 100, it's still just it's at 0. And then graphing this. 20 minutes before I arrived, there were 3,000 gallons. And again, my y-axis, the dependent, is volume of oil in gallons. And my x is time in minutes. And I guess I could title this Oil Left in Container, because graphs should always have a title. They should have, in the intervals here, what do they go by? 150, 300, 450, 600. So my intervals of oil are 150, and my intervals of time are in 10 minutes. 10, 20, 30, 40, 50. So let's just graph the points that we chose. I chose these points. If you chose different, that's fine. Just make sure your line, though, should graph the same as mine. So 20 minutes before I arrived, there were 3,000 gallons. 4 minutes before I arrived, 2,600 gallons. When I arrived, where it crosses the y-axis, at 2,500 gallons. 5.5 minutes after I arrived, there's 2,362.5. 15 minutes after I arrive, when time is 15, there is 21, 25. And again, that 15, if I came down, should be between my 10 and 20, right there. So, and then 90 minutes after I arrive, right there would be 90. There's 250 gallons left. And 100 minutes after I arrive, there's no oil left in the container. It's empty. So those are the answers to pages 170 to 173. Again, any questions on those answers? Review the video, and if you still have questions, please get a hold of me. Thanks.